Hey everyone, welcome. This is 1.3 part 3, the squeeze theorem. That says if f of x is in between h of x and g of x for all x in an open interval containing c, except possibly at c itself, then what we can have is some stuff. And we'll get right back to that. I just want to give you the quick, in the book they have a really nice thing here. And g is, like say, g is the larger function, h is the smaller function. You can see that real well. Let's just kind of zoom in here and there. Okay, so g is the larger one, h is the smaller one, and f is somewhere in between. And then at c, they actually get to be the same number. See? At c, they kind of just meet up at this one spot. That means probably at f, it's going to be the same limit. So let's look. The limit as h of x is L, and the limit as x approaches c for g is also L, and that means the limit for f of x at x approaches c is also going to be L. So no matter what happens, if it's in between, it's going to be, the limit will be the same as both of them. Kind of makes sense. The squeeze theorem, as you squeeze together, if f is in between, they're going to be the same thing. Okay, and here are a couple of special trig limits. The limit as x approaches 0 for sine x over x equals 1, and the limit as x approaches 0 for 1 minus cosine of x over x equals 0. Okay, so let's do an example with these special trig limits. So the limit as x approaches 0 of tangent x over x. So I look at this and say, I know tangent is going to be sine x over cosine x. Okay, so if I have an extra x in the denominator, I probably want to use this one and not that one because I have sine and cosine. So I'm going to try and use that special trig limit. So I can rewrite, what I'm just going to do is I'm just going to rewrite this part for now and we'll put the limit part back in. So tangent x over x is going to be the same as sine x over x times 1 over cosine x. Right? No problem. I multiply all those together. I get tangent x over x. Okay, so we get limit as x approaches 0 of sine x over x, and that's going to be multiplied by the limit as x approaches 0 of 1 over cosine x. Well, we know this whole thing is really from up here, so we know that whole thing is going to equal 1. And cosine of 0, if you remember from your unit circle, is actually just 1. So that means the limit as x approaches 0 is going to, of 1 over cosine x is going to equal 1 over cosine 0, which is the same as 1 over 1, which is 1. So if we have that whole thing, I'd have this 1 times this 1, and I get, oh, sorry. Oh, that's not so good. I kind of wrote all that down without you being able to see it. 1 over cosine x equals 1 over cosine 0 equals 1 over 1 equals 1. So I take this one, and I should put it here. Take this one, put it here. Multiply them together because sine x over x times 1 over cosine x. Multiply them together, and you should get 1 for your answer. Okay, good. Here's your very quick assignment. Find the limit as x approaches 0 of 4 sine x over x. And there we go. That's a little bit better. Sorry again. Hint, use the formula from 1.3 part 1. There's something in there that might help out just a little bit. Alright, and good luck.